Welcome back to Max with RP. Today we are going to do differentiation of inverse trigonometric functions. So I'm going to look at a specific type of differentiation where how you simplify helps you to differentiate much easier. So simplification of functions is the first step and then differentiation is the next step. We are going to look at problems which fall under this category. Now look at this particular problem. Sin inverse sin x plus cos x by root 2. So you have y equal to sin inverse sin x plus cos x by root 2. I am going to write this as sin inverse 1 by root 2 sin x plus 1 by root 2 cos x. So this type of writing or manipulation, as we call, will help you to simplify the function in a form which is much easier to differentiate. So this is sin inverse. This sin x, I am keeping it as it is. This 1 by root 2, I am going to write it as cos pi by 4. You know cos 45 and sin 45 are both equal to 1 by root 2. 45 degrees is pi by 4 radians. So this 1 by root 2 I am writing it as cos pi by 4 plus this 1 by root 2 I will write it as sin pi by 4 into cos x. So the function is simplified to sin inverse of sin A cos B plus cos A sin B, which is sin of A plus B. So I can write it as sin inverse sin of x plus pi by 4. Okay, so the function can be simplified and written as y equal to x plus pi by 4. So dy by dx is equal to 1. No restrictions on the domain or anything is given. So we are just differentiating, simplifying and just finding the derivative. Are you all able to follow? Is it understood? Now look at this problem. I'm going to actually today look at some problems of a similar type. Okay, how you can manipulate, simplify and then differentiate. This is y equal to cos inverse of root of 1 plus cos x minus root of 1 minus cos x by 2. This is further cos inverse of root of 1 plus cos x, you know, is root of 2 cos square x by 2 minus root of 2 sin square x by 2 divided by 2. This is cos inverse. Okay, now root of cos square x by 2 is cos x by 2. Now root 2 by 2 is 1 by root 2 minus root 2 by 2 is 1 by root 2. Root of sin square x by 2 is sin x by 2. Okay, now I can write this as cos inverse 1 by root 2, I can write it as cos pi by 4 into cos x by 2. I am using that substitution, whether cos pi by 4 or sin by 4, depending on whether I have cos inverse here or sin inverse here, minus sin pi by 4 into sin x by 2. Therefore, y equal to cos inverse of cos A cos B minus sin A sin B is cos of A plus B. So cos of pi by 4 plus x by 2. This is equal to pi by 4 plus x by 2. So dy by dx, derivative of pi by 4 is 0, derivative of x by 2 is half. So I have simplified the function and then differentiated. Now before we do this, actually, I want to talk about a particular derivation of how to simplify functions of the form tan inverse A plus tan inverse B. Okay, let us look at tan inverse x plus tan inverse y. Okay, now I am going to write x as tan A and y as tan B. Let x be tan A and let y be tan B. I want to simplify tan inverse x plus tan inverse y. Okay, then this becomes tan inverse tan A plus tan inverse. But even before that, I want to look at tan of A plus B first. Tan of A plus B, you know, is tan A plus tan B divided by 1 minus tan A tan B. Now tan A plus tan B by 1 minus tan A tan B is 1 x plus y by 1 minus xy. Okay, now this is tan of A plus B. So A plus B, what is tan inverse x plus y by 1 minus xy. Of course, this is defined only when xy is less than 1. This is an important condition. But what is A plus B? A is tan inverse x, B is tan inverse y. So tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy whenever xy is less than 1. Okay. Now look at this. Tan inverse here, there is no restriction on the domain. You are given just tan inverse 5x by 1 minus 6x square. You have to find dy by dx. Now tan inverse 5x by 1 minus 6x square can be written as tan inverse 3x plus 2x by 1 minus 3x into 2x. So this is what you should be able to see. Okay, so that I can bring it into a form which I am familiar with. The form being tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy whenever xy is less than 1. Okay, so this is the given function y equal to tan inverse of, this is like my a and this is my b, a plus b by 1 minus a b. So I can write this as tan inverse a plus tan inverse 3x plus tan inverse 2x. So now y equal to tan inverse of 3x plus tan inverse of 2x. Now dy by dx will be, what is the derivative of tan inverse x? 1 by 1 plus x square. Please remember, recall. If y is tan inverse x, dy by dx is equal to 1 by 1 plus x square. So this will be 1 by 1 plus square of 3x is 9x square into derivative of 3x, which is 3. This will be 1 by 1 plus 4x square into derivative of 2x, chain rule, into 2. So you have 3 by 1 plus 9x square plus 2 by 1 plus 4x square as the slope of the derivative, slope of the tangent. dy by dx is slope of the tangent at any point to the curve. Is 3 by 1 plus 9x square plus 2 by 1 plus 4x square. Now look at this. Y equal to tan inverse 4 into root x by 1 minus 4x. This I can write it as tan inverse 2 root x plus 2 root x by 1 minus 2 root x into 2 root x. So again I am bringing it into a particular form. I have collected a group of problems where the same technique will work so that you get proficient in this technique. So what am I doing? I am splitting this as 2 root x plus 2 root x, and this 4x I am writing it as 2 root x into 2 root x. So this is of the form tan inverse. Again this is A, this is B, this is A, this is B. So this is of the form tan inverse A plus B by 1 minus AB, which is tan inverse A plus tan inverse B. Which is tan inverse 2 root x plus tan inverse 2 root x. Which I can write it as 2 times tan inverse 2 root x is your y. Now I have to find dy by dx. Now dy by dx is equal to the derivative of this. What is the derivative of tan inverse x? 1 by 1 plus x square. So 2 times 1 by 1 plus, in the place of x I have 2x square. So 2 root x the whole square into derivative of root x. What is derivative of, see this 2 I have written here, then 1 by 1 plus 2 root x the whole square into derivative of 2 root x. What is the derivative of 2 root x? That will be 2 into, what is the derivative of root x? 1 by 2 root x. This 2 comes because of that. Then derivative of tan inverse x is 1 by 1 plus x square. So 1 by 1 plus 2 root x square into chain rule. Derivative of 2 root x, 2 into derivative of root x, which is 1 by 2 root x. Therefore, this becomes what? 2 by root x into 1 plus, this is what? 4x. 2 square is 4, root x square is x. So 2 by root x into 1 plus 4x is the dy by dx. It is the slope of the tangent at any point to the curve. Are you able to follow how to simplify these type of functions? Now look at this. Y equal to tan inverse 2 power x plus 1 by 1 minus 4 power x. Now this I can write it as tan inverse 2 into 2 power x. 2 power x plus 1 is what? 2 into 2 power x. Now 1 minus 4 I can write it as 2 square power x. Now this can be further simplified as tan inverse 2 into 2 power x by property of exponents I can write this as 2 power x the whole square. 2 power 2x, I can, by property of exponents, I can write 2 power 2x as 2 power x the whole square. Both are one and the same, right? Now this is of the form If I call this as say A, this as A, then this is of the form what? Y equal to tan inverse 2A by 1 minus A square. Tan inverse 2A by 1 minus A square is see, this is of the form tan inverse 2A by 1 minus tan square. This is nothing but tan inverse tan 2A. Okay. Tan 2A formula is what? 2 tan A by 1 minus tan square A. Okay. So this can be written as what? Tan inverse. Okay. Now 2 tan theta by 1 minus tan square theta. What is tan theta? 2 power x is tan theta. I am writing 2 power x as tan theta. So this becomes tan inverse of 2 tan theta by 1 minus tan square theta, which is tan inverse tan 2 theta. Okay, which is 2 theta, which is 2 times, what is theta? Tan inverse 2x, tan inverse 2 power x. So we have only simplified the function, we have not yet differentiated. So y equal to this. Okay. Now what will be dy by dx? Dy by dx will be 2 times derivative of tan inverse x is 1 by 1 plus x square. So 1 by 1 plus 2 power 2x. 2 power x the whole square the same as 2 power 2x into derivative of 2 power x. Derivative of 2 power x is 2 power x log 2. Recall. If suppose you have say t equal to 2 power x, log t is x log 2. So 1 by t dt by dx is log 2. So dt by dx is t into log 2, which is 2 power x log 2. Please recall, this is what we have done when we did logarithmic differentiation. So derivative of 2 power x is 2 power x log 2. Okay. So we have dy by dx equal to, so dy by dx equal to, okay, 2 power x plus 1, because we have 2 into 2 power x log 2 by 1 plus 2 power 2x. This is the derivative. So this is the slope of the tangent to the curve at any point. Are you able to follow how we got it? So you must recall the earlier, earlier ways of simplification of differentiation that we have learned using implicit forms as well as logarithmic differentiation. Now look at this problem. Y equal to tan inverse this, you have to find dy by dx. See, when you look at this, see, this root of 1 plus x square itself should suggest what substitution we can make. We know that 1 plus tan square theta is secant square theta. So the natural substitution that we can make is, let x be tan theta. Then 1 plus x square will be 1 plus tan square theta, which is secant square theta. Okay. Root of 1 plus x square will be secant theta. So this function y simplifies to tan inverse secant theta minus 1 divided by what is x? Tan theta, which is tan inverse 1 by cos theta minus 1 divided by sin theta by cos theta. So this is for the tan inverse. What will you get? 1 minus cos theta by sin theta. Because the denominator gets cancelled, which is cos theta. So y equal to tan inverse. What is 1 minus cos theta? 2 sin square theta by 2 divided by sin theta. Sin A is 2 sin A by 2 cos A by 2. So this is 2 sin theta by 2 cos theta by 2. So y equal to tan inverse of 1 sin theta by 2 gets cancelled, giving you tan theta by 2. 1 sin theta by 2 gets cancelled. So you have tan inverse of sin theta by 2 by cos theta by 2, which is tan inverse of tan theta by 2. So y equal to theta by 2, which is half into, what is theta? Theta is tan inverse x. Implies theta equal to tan inverse x. So we have only simplified till now. Only now I am differentiating. dy by dx will be half into derivative of tan inverse x is 1 by 1 plus x square. So dy by dx is 1 by 2 into 1 plus x square in the denominator. So we have been looking at some of the problems involving inverse trigonometric functions. Okay, I have been just looking randomly, taken a few sums which where you have to manipulate and differentiate. Okay, I hope you understood and got the technique. Please practice plenty of sums, and if you find this video useful, please do not forget to share it with your friends. Please practice these sums again and again until you get the mastery of it. Wishing you the very best, and until we meet next time, it's goodbye.